Algebra 1, Lesson 30. Solving word problems with systems of linear inequalities. When dealing with real-world problems, we often encounter situations where we need to make decisions within certain limits or constraints. For example, if you have a limited amount of time and money, you might need to decide how much of each resource you can use. In these cases, systems of linear inequalities can help model these constraints, allowing us to find feasible solutions. These are the usual steps you'll need to take to solve word problems with systems of linear inequalities. 1. Understand the problem. Read the problem carefully to identify what quantities the variables will represent. 2. Define the variables. Assign variables, such as x and y, to represent the unknown quantities. 3. Write the inequalities. Based on the problem's constraints, write down inequalities that represent these limits. 4. Graph the system of inequalities. Plot each inequality on a graph to find the solution region that satisfies all inequalities. 5. Interpret the solution. Analyze the feasible region, where all inequalities overlap, and check if it answers the problem's question. Example 1. Emma is planning a fundraiser where she will sell baked goods, cookies and brownies. Each cookie takes 2 minutes to make, and each brownie takes 3 minutes. She has a maximum of 5 hours, 300 minutes, available for baking. Additionally, she wants to make at least 50 items in total, but no more than 100. Write a system of inequalities to represent this situation and find the feasible solution set. Let's get started. First, we need to define the variables we will be using in the system. We can let x be the number of cookies Emma bakes, and let y be the number of brownies Emma bakes. Next, we'll need to identify the constraints. We know that each cookie takes 2 minutes, and each brownie takes 3 minutes, and she has a maximum of 300 minutes. This translates to the inequality 2x plus 3y is less than or equal to 300. Now we need to write inequalities for the total items constraint. Emma wants to make at least 50 items but no more than 100. We can write 2 inequalities that represent the constraint. X plus y is greater than or equal to 50, and x plus y is less than or equal to 100. Now let's put all the inequalities together and go from there. Here we have the 3 inequalities we just figured out. Now we must figure out the best way to solve this system of inequalities. If you remember from the last lesson, my preference is to graph systems of linear inequalities and figure out the shaded region that contains all the real solutions. So let's do that right now with this system. Pause now and try to figure out the graph yourselves. The correct graph will be on the next part. Your graph should look something like this. The solution set is the region that is the darkest shaded. For more clarification or help, if you had trouble making the graph, here are the 3 inequalities listed with their x and y intercepts. To finish the problem, here is how we interpret the solution. The darkest shaded overlapping area on the graph shows the feasible values of x and y, meaning the combinations of cookies and brownies Emma can bake within her time limit and quantity requirements. Any point in the overlapping region is a possible solution, such as the coordinate point, 40, 60, meaning 40 cookies and 60 brownies. In this lesson, we learned how to translate word problems with constraints into systems of linear inequalities. By defining variables, writing inequalities, and graphing them, we can find a feasible solution region that meets all the problem's conditions. Practicing with these kinds of problems will help you understand how systems of inequalities can be applied in real-world situations, from budgeting to planning and optimizing resources.